let's get into it. And I can tell you that the question is also explored in other places on the web in certain ways. It becomes something of a punchline in JavaScript that truthiness and falsiness exist. And it's really possible in a weakly typed language to have what we're going to go through. The question is, for what reason does the left side of this evaluate as true when compared to the string nerd, capital N, lowercase ERD? And it all comes down to falsy checking. It comes down to weak typing. It gets down to some things that get commented on as silly in JavaScript. And I'll take it step by step. So if you look at this piece of it, this is where the N is coming from. If you look at this piece of it, this is where the E is coming from. If you look at this piece of it, this is where the R is coming from. And this piece is going to be where the D is coming from. I'm going to strip away everything after where the N comes from and talk to how this ends up evaluating to N in a piece-by-piece way. So you'll notice that there are two plus signs here. There is plus, which is being used as an addition operator. And then there's also a plus that's being used to cast a string to, cast a number to a string. And I'll start with that. So let me put this up in the URL just for safekeeping and do this. Here's the number 1. We'll say let x equal to 1. So when we evaluate x, it is going to be equal to 1. If we do a plus x, you get that. If I do, oh, I have to walk into this from a different direction, and again state that the plus is for when you've got a string and you need to cast it out to a number. So we'll say x is equal to the string, which is 1, and then do plus 1. And what it's showing you is that when it evaluates to the number 1. So to be clear about this in another way is to say, what is the value of x? You can see in console, it's going to print out 1, and it's in a string. And then if you do plus x, what is the value that gets consoled is a number. So now we've casted from a number, from a string to a number. Let's look at what an array is. An array will evaluate to an array. What a plus array will evaluate to is a 0. If you take that piece here, now we're at a 0. If we take what is 0 at the 0 index, it's undefined. All right. So we've gotten to the point where we're at undefined up there. And now we're doing an addition from what is a undefined plus a empty string. So if we type undefined plus an empty string, what do we get? We get it to be a string. And then when we get that string undefined and take what there is the index at 2, we get a D. So we've got a D. Let's look at the original copy paste job from the Slack. Copy that. All right. We wanted that to be an N. And here it's an N. There it is not. What is different? Let's look at it. There's a parentheses in here. So if we take what we did before, which is evaluate to the point that undefined is there. You still get your D. So let's go through that and work out where the error is at. We got the empty array. You want to know where it's at 0. That gives you what you'd expect. And then you get to the string, and then you get the N. So you get nan. Oh, okay. So let's look at how these get evaluated. What is array at 0? Array at 0 is undefined. Plus undefined gives you nan. And then we evaluate nan there. This is all a result of precedence. So the first thing that gets evaluated is what is directly to the left of that unary plus, undefined. And then the unary plus is tacked on to give you nan, and then the empty string gives you nan as a string. So the peculiarities of at which point in time any of this gets evaluated, and for what reason adding an empty string to a value like nan or undefined gives you that version as a string are trivial. This is all part of the sort of joke of the question is, why does this have some translation to this? Clearly, programming and programmers day to day are not ever needing to evaluate this. What we reveal in this anyway is this plus operator, which a lot of utility exists in. To do this is more brief than to do another form of going from a string to a number, which is to do a parse int with a base 10. And parse int has value when you're working with hexadecimal and so on, but you usually aren't. So you can learn from this that occasionally you're going to get a number from your database. You might have some object that's a response body from the server, and it'll have an ID on it, and that ID will be a string, and you'll have a value on it, and that ID will be, that value will be a number, and it'll also be as a type of string. And you want to do some math on it. So we'll picture that we have 2 bodies. So we can do let bodies is be an array where the first one is a body and the second one's a body. So when we've got our bodies, it's there. And we want to do some math on those values. So we want to add up the value of the first one. We say value plus bodies value. And what do we get is a syntax error. That was an unexpected punchline. Here it is. 25, 25. When you add 25 and 25, you're really expecting a 50. But what you've done is concatenated 2 strings and not evaluated math. So when you're in that situation, the most straightforward way to handle it, they're strings. You can add your unary operators to cast them to be numbers. Now you get the math that you would think. So the first bit of this is understanding that unary plus. So we've got ourselves an M. Let's work to get a E. We've got an E. All right. Let's break it down like we did before, starting with the array and then adding a couple of not operators, negation, logical negation. You see a double bang when you're attempting to coerce something's truthy value strictly into a Boolean. So 0, not 0 is true, because in JavaScript, not 0 being loosely equal to false is accurate. 0 is falsy, false is falsy, and when you're using equality checks that are not strict, which is when you do a double equal, it evaluates to true. If you triple equal it, it'll be false. So now you've got something that's falsy being strictly compared to something that is literally false. What you would do when you wanted to know that this falsy thing is in fact falsy is to do a double bang operator on it. Because what that'll say is, give me this false-ish thing and tell me, is it false? Great. That solves our evaluation up to the point where we've got the double bang, and then we, in the E there, we take that double bang, it evaluates to the string called true, then we take the 3 index, and then we get ourselves an E. We go further into it. This example is less educational. It builds on what we learned in the next one, in the first one, which is that this evaluates to true. And then we take the 1 index, which is your R. Finally, we get a D, which when we look at what is the 1 index of an empty array, that's going to be undefined. We cast that into a string, and then we take the 2 precedence matters, and then you get that string to be a D. There's our D. All in all, the left side is equal to nerd. And I'm missing the front of that. So at whichever point I went through the front, I cut it off, take that full question again, put it over there, and we get to true.